Okay, good morning. Welcome to
Math number 807.
Math number 807. So we're going to talk about the Mobius strip and some other objects today. So ahead of time I had you make a Mobius strip.
Yep.
First of all, actually, I guess explain what you do to make it, and then you can tell me about sort of what interesting properties it has.
Alright, so what you do...
You don't need, you can just talk about it. You don't need to make one
So, yeah, you got a piece of tape, and you have a strip of paper. So, you do the paper, give the paper a half twist, and you fold it back on.
So make sure you're on, yeah, move it down here.
Like this, and then you tape up this edge, and you've got a Mobius strip.
Okay, and that's, so let go of that one. So just take a flat sheet of paper and give it a half twist, tape it up, and you get an object that looks like this. And what are some interesting properties that you know about in relation to the Mobius strip?
Well, it only has one side.
Okay, what does that mean?
So if you take your finger and follow it all the way around the Mobius strip, you're gonna end up back where you started, and
you'll travel all of the Mobius strip.
Yeah. So if you do this for like a regular piece of paper, just fold it up, taped up. It just goes.
You'll never get to
the inside.
Okay, so that has two sides.
Yep. But this, you always all of it with just going all the way around. So it only has one side.
Okay, that's interesting. What are some other properties that you know about with regard to the Mobius strip?
Well, so we know it's a flat surface.
Yep. Sorry, I'm gonna move these things up a little bit. It's a flat surface. So what does that mean? That it's flat?
So it means that you can construct it from flat sheet of paper.
Okay, so yeah, so that's actually a pretty advanced property. But unlike, say, a sphere, which is not flat, which cannot be made from a single sheet of paper, the geometry that you learn in your books, in your geometry books, applies on a Mobius strip. So triangles have angles that add up to 180 degrees, things like that.
Yep.
So it's interesting that the geometry on a Mobius strip is unchanged from the geometry on a regular plane. So that's neat, and there are other objects for which that's true. In fact, we'll be talking about some more of those today.
All right.
Any other properties?
Well, when you cut it, it doesn't cut in half.
Oh yes, when you cut a Mobius strip. What do you mean by cutting the Mobius?
Like if you cut down the middle, like if you start here, you sort of cut around the middle, the Mobius strip. So it doesn't cut in half. Whereas if you just had the loop like this would cut into two shapes. This stays one shape.
Yeah, so it's interesting when you cut it in half down the middle. Like if you imagine drawing a line down the middle of this Mobius strip, and you cut down that line, you'll get a nice surprise if you haven't seen it before. Okay, so this is actually really interesting. One other property I want to point out about the Mobius strip that we're going to encounter a little bit more in just a second is if you started, do you have a pen or a pencil nearby?
Let's go get one.
All right, we'll play the Jeopardy music in your head while we're getting a pencil. If you start taking a walk around the Mobius strip, and so you're always pointing up like this.
Yep.
And you just take your little walk. What surprising thing happens?
Well, now you're actually pointing down.
Okay, so here I'm pointing up, but when I was,
Yeah.
I'm actually opposing on the opposite side, even though there's only one side.
Yeah.
This arrow is actually pointing now in the opposite direction of the original arrow. So that is a property that we're going to study right now.
All right.
Okay.